Imagine you are standing inside a spacecraft 70 million kilometers from home, approaching the edge of the sun. Through the reinforced viewport, you see something that defies everything you thought you knew about fire, about heat, about destruction itself. The surface below glows at a comfortable 6,000 degrees. Hot, yes, but manageable. Your heat shield was designed for this. Your instruments were calibrated for this. But above that surface, reaching out like ghostly fingers into the black void of space, is the corona. And up there, in that ethereal halo of light, the temperature doesn't cool down as you'd expect. It rises. It skyrockets to over 2 million degrees Celsius. And in that moment, you realize you've entered the most corrosive environment in the solar system. The corona doesn't look dangerous. That's the terrible beauty of it. It looks like a crown of light, delicate filaments of plasma dancing in magnetic fields, glowing with an otherworldly radiance that poets would die to describe. If you could see it with your own eyes during a total solar eclipse, you'd think you were witnessing heaven itself. Streamers of ionized gas stretching millions of kilometers into space, shimmering with colors no camera can quite capture. It's gorgeous. It's mesmerizing. It's the kind of beauty that makes you forget you're looking at a killing field. But something is wrong. Your instruments start screaming numbers that don't make sense. The surface of the sun beneath you is 6,000 degrees. You're moving away from the heat source, up into the corona where logic says it should be cooler. But the temperature gauge is climbing. 7,000 degrees, 20,000, 100,000, and it keeps going. Your training tells you this is impossible. Heat should dissipate as you move away from the source. But here, in this thin veil of plasma, thermodynamics seems to have abandoned the universe entirely. 2 million degrees Celsius, and rising. Here's the problem. At those temperatures, matter doesn't just melt, it doesn't burn. It transcends the very concept of chemistry. Every single atom is moving so fast, vibrating with such violent kinetic energy that molecular bonds don't stand a chance. Forget sulfuric acid eating through metal. Forget aqua regia dissolving gold. Those are chemical reactions, electron exchanges, orderly processes governed by rules. The corona doesn't follow rules. It operates on a level of violence that makes acid look gentle. In the corona, atoms are ripped apart into their constituent pieces. Electrons are torn from their nuclei with such force that matter itself stops being matter in any meaningful sense. You're not in a place anymore. You're inside a storm of naked protons and free electrons, a plasma so energetic that the very fabric of what we call solid or liquid or gas becomes irrelevant. Everything becomes ionized ghosts. But it gets worse. The Parker Solar Probe knows this intimately. Launched by NASA in 2018, it's the closest humanity has ever come to touching the sun. Its mission, dive through the corona, measure what we can't see from Earth, and somehow survive. The probe has a heat shield made of carbon composite foam, nearly 12 centimeters thick, designed to withstand temperatures exceeding 1,400 degrees Celsius. Behind that shield, the instruments stay cool, functioning at room temperature while mere meters away, the universe is trying to annihilate everything that exists. And even that isn't enough to go deep. Because here's what the probe discovered. The corona isn't just hot, it's selectively violent. The magnetic fields threading through it create pockets of extreme turbulence, regions where temperatures spike even higher, where plasma accelerates to a significant fraction of the speed of light. These are called magnetic reconnection events. When they happen, they release more energy than 1 billion nuclear bombs in microseconds. The corona doesn't just dissolve matter, it weaponizes physics itself. And here's where things change. You need to understand what corrosive means in this context. When acid corrodes metal, it's a slow dance of atoms. The acid donates protons, the metal accepts them, electrons shuffle around, and gradually the metal breaks down. It takes time. It follows chemistry. But in the corona, there is no time. There is no chemistry. There's only impact, kinetic annihilation. The plasma particles are moving so fast, thousands of kilometers per second, that when they hit anything, they don't react with it. They obliterate it. Imagine your ship hull is made of the strongest material we've ever engineered. Titanium alloy, carbon fiber, doesn't matter. In the corona, those materials don't get a chance to resist corrosion. The atoms of your hull are immediately ionized on contact. The electrons are stripped away. The nuclei are bombarded by particles moving at such speeds that they're knocked loose from their lattice structure. Your ship doesn't corrode, it evaporates, atom by atom, layer by layer, faster than you can blink. But that's not even the worst part. The worst part is that we don't fully understand why the corona is so hot in the first place. The surface of the sun, the photosphere, is 6,000 degrees. That's the nuclear furnace doing its work, fusing hydrogen into helium, releasing energy. Logic dictates as you move away from that furnace, temperatures should drop. And they do it first. In the chromosphere just above the surface, it cools to about 4,000 degrees. But then, in the corona, it explodes upward to millions of degrees. This is called the coronal heating problem, and it's one of the greatest unsolved mysteries in astrophysics. We have theories. Magnetic waves carrying energy upward, nanoflares, tiny explosions happening constantly invisibly, turbulent plasma interactions. But theories aren't answers. And what terrifies scientists is this. If we don't understand why the corona is hot, we don't understand what else it might be capable of. The Parker Solar Probe has given us clues. It's detected something called switchbacks, sudden reversals in the magnetic field that whip through the corona like cosmic cracks. These switchbacks accelerate particles to incredible speeds, heating the plasma even further. They're chaotic, unpredictable, and they suggest that the corona isn't a stable environment. It's a perpetually collapsing system on the edge of catastrophic instability. And here's where the fear deepens. You're not just dealing with heat, you're dealing with radiation. The corona emits X-rays and extreme ultraviolet light at levels that would fry your DNA in seconds. It's a bath of high-energy photons that don't just burn your skin, they shred your cells at the molecular level. Your body's molecules would be ionized just like the hull of your ship. Your proteins would unravel, your DNA would fragment. You wouldn't die from heat stroke. You'd die from ceasing to be chemically human. The solar wind born in the corona carries this violence outward. It screams across the solar system at speeds exceeding 500 kilometers per second, carrying charged particles that slam into planets, strip away atmospheres, and create auroras where magnetic fields try desperately to deflect the onslaught. Our planet's magnetosphere barely keeps this at bay. Mars lost most of its atmosphere to the solar wind billions of years ago. Without our planet's magnetic shield, the corona's reach would have dissolved our oceans, sterilized our surface, and rendered Earth as barren as the moon. But it gets worse. During solar storms, coronal mass ejections, the sun hurls billions of tons of plasma directly into space. These aren't gradual releases. They're explosive, violent, and when they hit Earth, they can cripple satellites, damage power grids, and expose astronauts to lethal radiation doses. The Carrington event of 1859 was one such storm, and it caused telegraph systems worldwide to fail, some catching fire. If a storm of that magnitude hit today, our technology-dependent civilization would face trillions of dollars in damage and potentially years of recovery. And that's just from the corona's breath reaching us from 150 million miles away. Imagine being inside it. The Parker Solar Probe gets within 6 million kilometers of the sun's surface at its closest approach. That puts it deep in the corona. And even with all our engineering, all our preparation, the probe can only survive for brief periods. It has to dive in, take measurements, and retreat, because staying in the corona isn't an option. Not for our technology, not for anything we can build. Because the corona doesn't just destroy through temperature or radiation or particle bombardment. It destroys through all of them simultaneously. It's multi-vector annihilation, a place where chemistry stops, where material science fails, where the comfortable rules that govern existence simply cease to apply. Acid corrodes through predictable chemical pathways. You can engineer around it. You can neutralize it, contain it, understand it. But the corona? The corona is corrosion elevated to cosmic violence.